now that we've learned some of our rules for exponents, we're going to look at how we can use those rules to simplify some expressions. Okay, so let's start with example 6n to the 5th power over 8n squared. Okay, and for this first set, I only want to use positive exponents. Okay. Only use positive exponents, all right? So essentially what I'm going to do is I'm going to kind of split this into two groups. I'm going to split it into my numbers, my coefficients, and deal with those first, and then I'll deal with my variables and the exponents, okay? So let's start with 6/8, right? If I just said simplify 6/8, okay, we know that simplifies to 3/4, just simplifying a fraction. Those are both divisible by 2. So the same thing is going to work here. Okay, we're just going to make the coefficients and turn that into 3/4. All right. Now, if we focus then on the second part, n to the 5th over n to the 2nd. Well, it's division, and we just learned in our previous thing that when we want to divide, right, we have to subtract those exponents, right? So n to the 5th divided by n to the 2nd, right? We want to do subtraction, right? N to the 5 minus 2 power, or more simply, n to the 3rd power, okay? So what we end up with then is 3/4 n to the 3rd power as our solution, okay? And our n to the 3rd power goes in the numerator because, again, we have more exponents in the numerator versus the denominator. So if you get a little confused, where does that go, right? It's going to end up in the numerator. So we end up with, that's simplified. It's got positive exponents, okay? So we're good to go on that one. Let's look at one that's a little bit trickier, okay? Again, we only want to use positive exponents on this. Let's say we had something like 10n to the 4th over 20n to the 8th. So again, I want to first deal with my coefficients. Well, 10 over 20, right, is equal to a half. So we're just going to simplify it again, just like we would a fraction. Okay? N to the 4th over n to the 8th, right, is equal to n to the 4 minus 8 power. Right? We have to subtract when we are dealing with division. So that would simplify to n to the negative 4th. So if I put those together, I end up with 1n to the negative 4th, or more simply, n to the negative 4th over 2. Okay? Well, again, my stipulation is I don't want to have negative exponents. I only want positive exponents, right? So that we've got to then think about, well, what do I do to get rid of my negative exponent? So we go back to that rule for negative exponents, right? A number to a negative exponent, I think the example we use something like 10 to the negative 2nd, right, is equal to 1 over 10 to the 2nd. Okay, so in this particular case, n to the negative 4th, we use the positive form of the exponent and put it in the numerator, and then our denominator becomes 1. Okay, so now if we put that all together, right, I've got the first part is 1/2. I've got the second part is 1 over n to the 4th. Okay, if I combine that together, right, I get 1 over 2n to the 4th power. Okay, again, we simplified the first part. 10 over 20 simplifies to 1/2, right? N to the 4th divided by n to the 8th is n to the negative 4th, right? And if we want to make it positive 4, we have to put it in the denominator. So we end up with 1 over 2n to the 4th power. All right, have to have that 1 up top because we need something there as a placeholder. All right, let's look at one more example. This one will deal with multiplication. Okay, so 8n squared times 5n to the negative 5th. All right, now we know multiplication is commutative. We can change the order around, so we're going to change the order of this around. Okay, I've got 8, remember that means times n squared, times 5, times n to the negative 5th. So I'm going to regroup my coefficients together. Okay, and this could be something, it could be mental math. You don't necessarily need to write this step out, but this is the thought process you go through. And then I'd group together my variables. Okay, So a times 5 is 40. N squared times n to the 5th. Again, our rule with multiplication is we add. Right, 2 plus negative 5. So that's equal to 40n to the negative third. Right, now our rule is, again, we don't want negative exponents. So I want to get the negative 3 and make it positive, right? As we just saw in our previous problem, okay, when we make it positive, it's got to move down to the denominator. So n to the negative third, I make n to the positive third and move in the denominator. Okay. Now, here's sometimes a little bit tricky part, right? The negative third is not on the 40. It's only on the end. The 40 doesn't move. Okay. It's not this whole thing to the negative third. It's just the n. The 40 is not there. So the 40 remains in the numerator. We don't drop that down because it's not 40 to the negative third, n to the negative third, or 40 times n, that whole quantity, to the negative third. It's just the n. So when we make that negative 3 positive, it moves into the denominator. The 40 has to stay there. It doesn't change anything because it's really 40 to the first power. So we don't have to move it. Okay. So just to recap, we multiply together our coefficients. Okay. We follow our rule for multiplication of exponents by adding. And then in this case, we have a negative. We make that positive and drop it down to the denominator. Okay. Anything that doesn't have a negative exponent stays in that numerator. So we end up with 40 over n to the third power. Okay. Now let's look at an example where we might do the opposite. Okay. Where I want to use negative exponents because I don't want a fraction. So let's say it's something like 6n squared over 3n to the 5th. Okay. And I want to rewrite this without a fraction bar. Okay. Sometimes fractions aren't real nice to work with. So if we can get rid of fractions, we'll get rid of fractions. Okay. So again, let's start out with the coefficients, right? 6 over 3, well, that simply simplifies to 2. Okay. N squared divided by n to the 5th. Well, our rule is we subtract exponents. So 2 minus 5 is negative 3. Don't have a fraction bar. Okay. So it fits what I'm looking for there. All right. So that one's fairly simple. Let's look at another example. Okay, so this time, get that erased here. There we go. Let's start with 6x over 2y. Okay, so again, we'll start with our coefficients. 6 over 2 simplifies to 3. Okay, now I want it without a fraction bar. My x is good. It's already in the numerator. I don't need to do anything with that. Okay, what I want to be able to do, though, is take that y and move it up into the numerator so it's no longer in the denominator, right? Well, we learned that if we have a negative exponent, I can make that positive by putting in the denominator, right? N to the negative first is equal to 1 over n to the positive first. Well, I can also do that the other way. If I have something in the numerator, if I make the exponent negative, right, I can move it out of the denominator. I'm sorry, if I have an exponent in the denominator, I can move that out of the denominator by making the exponent negative, right? Now, y doesn't have an exponent that's showing, right? But we know that if it's not there, it means to the first power. So what can I do to that first power to get it out of the denominator? I can make it negative. So 3x, if I want to bring the y up, I make the denominator negative. 3xy to the negative first power would be that simplified without a fraction bar. Okay. All right, let's do one more example here. One more. Sometimes if we have just a regular fraction, okay, we want to rewrite that again without a fraction bar. Okay. If we can get a number and we can turn it into an exponent, that'll help us to do that. So for example, let's say I had something like 1/9, and I don't want the fraction bar. I'm not going to change to a decimal. I'm not talking about that. I want to use exponents to rewrite it without a fraction bar. Well, I've got to think about 9. Is there an exponent that I can use that is equivalent to 9, right? Well, most of us know, right? 3 squared. 3 squared is 9. So I have an exponent now. Okay, and if I want to move it out of the denominator, as we just saw in the previous one, I simply have to make that exponent negative, right? So 1 over 3 to the second power is equal to 3 to the negative second. Okay, if I have something like 1 over 16, well, 16 is 2 to the 4th power, right? So if I want to move that out of the denominator, I simply make that exponent negative, right? It's like a switch. You take the switch off, it drops down to the denominator, you put the switch back on, moves up, right? If you've ever been in a fancy hotel and you have to have the special key card to move into the penthouse at the top floor, same idea, right? Give the number its key card, right? And to the 8th, I give a key card to the 8, make it negative, moves on up to the penthouse, right? It becomes into the -8. If I take a key card away, then it's got to drop back down.